All right, we're back to looking at a few more atomic models to kind of finish up some of the history here of what we need to know for the atomic model. We already have looked at Rutherford. We know that with his gold foil experiment, he was able to discover that there was a nucleus and that all of the protons, the positive charged particles, were in the nucleus. And so his model is called the nuclear atomic model because of the nucleus. But his model did not really give any explanation for the chemical properties that an element has. And so it wasn't until Niels Bohr, and he was mentioned in the web quest, that he was able to kind of do something with electrons. And so he said that electrons can only possess certain amounts of energy, and because of the energy that an electron possesses, that kind of tells us where the electron is in compared to the nucleus. So like the closer you are to the nucleus, the less energy you have, and the further away, the more energy you have. So his is referred to as the planetary model because we actually now we have, here's our nucleus still that Rutherford came up with, and our protons and neutrons in the nucleus. But before that we just had the electrons kind of scattered anywhere. And now Bohr is specifically putting them on these lines, okay, these energy levels or these shells. So it represented or looked like planets orbiting the sun, and so it was nicknamed the planetary model. Bohr calculated some possible locations that an electron might be, and he called those shells, those lines that I kind of highlighted on the previous screen. And the shells or energy levels are located at discrete distances, means specific distances from the nucleus. So it's, you know, kind of a set pattern. And then the closer you are to the nucleus, I mentioned, the lower your energy is. And he also said that if you're within the same shell, then you have the same amount of energy. So if here's our nucleus, we have our first shell, our second shell, and he had electrons on these shells. If you're in the same shell, like these three electrons right here, they have the same amount of energy because they're in the same shell. Now they can have a different amount of energy than these two because the shells are different distances from the nucleus. But if you're within the same shell, you have the same energy as all the other electrons in that same shell as you. Now, as far as energy levels, okay, they are kind of like rungs on a ladder. And so if you think about a ladder, you have, you know, maybe here's your nucleus, so here's, you know, you're getting further away from the nucleus as you go on the rung of a ladder. And the electrons can move from energy level to energy level, just like our foot can move to a different rung on the ladder. But you can't exist between energy levels. So an electron can't kind of be hanging out here between levels. They have to be located on a level, just like our foot. You know, you're not going to be safe trying to stand on midair. So that's kind of what the energy levels represented for Bohr, were these like rungs on a ladder, different distances away from the nucleus, and each distance has a different energy associated with it. And he said that the further away from the nucleus you are, the higher the energy level is going to consistently be. So you get to the third level, you have more than the second and the first. You get to the fourth level, you have more than the third and the second and the first, and so on. Now, how do electrons move? Okay, electrons can move from energy level to energy level, and he said that they can move when they gain or lose energy, and that's called a quantum. So when you hear about quantum mechanics, you're talking about energy. Yeah, so unlike an actual ladder, though, where on that previous picture there's about the same distance between, you know, step to step, energy levels work more like this model here, where here's maybe energy level 1. To get to the next energy level, maybe you have a short distance, and eventually you notice your distances between energy levels is increasing. And so when you need to gain or you need to lose energy, but it's not going to be the same amount of energy to get to the next level that you're already in. So if you want to jump to the next energy level, that's okay, but you need to gain enough energy to be able to do that. You can't, you know, hang out in the middle like he mentioned. Some drawbacks to Bohr's model. His model works great, but really only for hydrogen. If you have more than one electron, then this whole absorbing energy and so on didn't adequately explain what would happen if you had more than one electron, but it really is a perfect model of hydrogen, and it still is. So we're going to talk about one more person, and his name is Schrodinger. And this is a common name. You'll hear them mention Schrodinger on the Big Bang Theory if you watch that TV show occasionally. But he deals more with a quantum model, so more of an energy model than what Bohr did. And he specifically talked about the energies that an electron can have, and specifically your chances of being able to find an electron compared to the nucleus. So he's going to use probability, and we'll talk more about probability, but in math, probability, the chance or the likelihood of an event happening. And so he was specifically looking at the chances or the likelihood of finding an electron in a certain location. He is going to not refer to things so much as the shells that Bohr talked about, but he's going to call things an electron cloud. So the cloud is the area around the nucleus, because that's where you find electrons, is outside of the nucleus. And if the cloud is very dense in his probability model, the more dense an area is, the likelier you are to find an electron. And when the cloud is less dense, then there's less of a chance. And this is the only person I didn't provide a model with. So if this is your nucleus, this really reminds me in art when you do like the dot pictures, you can make some really cool things. I'm not going to go all the way around just for saving time, but here you can see there is a lot of dots. So it is very dense, and in his model you'll see all these dots, and sometimes the dots are really close together and really thick looking, and other times they're very more spread out. And so in this dense area you have a high chance of finding an electron because it's very dense, very thick there. But in this outlying area where you start to, you have less dots, then you have a lower chance of being able to find an electron in that area. So he used probability and likelihoods and chances of finding an electron instead of stating that they had to be on a certain rung or a certain energy level. He said they could be anywhere within a certain area. So that's kind of how Bohr and Schrodinger, how their models differed. And we'll continue to talk about Schrodinger as we get into more about how electrons are arranged. But that's just a little bit to introduce him and to kind of finish the history. That's as far as we're going to go. Currently, the model that we hold to is this electron cloud model.